Hi all. Okay, we're going to move on to our last session on subtracting fractions. Where's it gone? Let's go to full screen. There we go. Right. So this time we've got another. It looks more confusing than it is actually. We've got orange shirt and we've got yellow shirt. Orange shirts used 1 1/4 pounds of flour. Yellow shirts use 1 7/8 pounds. What you can't read, even though I've done it bigger, is that these bags are 2.5 pounds. Now, the question looks more confusing than it is, but actually it asks how much flour is left in each bag. So it's basically two different questions. So let's just look at the first part here with orange shirt, who's used 1 1/4 pounds of flour. That means this calculation we're trying to solve is 2.5 pounds, that's the size of the bag, take away 1 1/4, that's how much she used. So 2.5 take away 1 1/4. There are two different methods that we might use for this calculation. I'm just going to say this now. On your worksheet, it's obsessed slightly with the names of the characters, and it calls, I can't remember her name, Sarah's method, let's say. Don't worry too much about that. The methods are less formal methods. They're just different ways of approaching problems. So there are lots of different methods. We're not going to get caught up and stressed out about the naming of those methods. It's a waste of time. What we know is there's different ways of doing it. One way we might solve this problem is by looking at our 2.5. So what I might do is say that this is actually the same as 2 2/4, because I know that that half is the same as 2/4. Now I know I've used 1 1/2. So I've used one whole strip that I can get rid of. And then I've used 1/4 to one of those. So then I could see visually that leaves me with 1 1/4. So what she's done is take 1 away from 2, and then she's taken her 1/4 away from 2/4, and then combines those answers. So it's a bit like partitioning and then recombining. I've looked at my whole numbers, and then I've looked at my fractions, and then I've recombined them. 2 take away 1 is 1. 2/4 take away 1/4 is 1/4. So my answer is 1 1/4. So for some questions, that kind of partitioning method, partitioning out the whole number from the fraction, works. You could also have turned it all into quarters. I had 2.5, and I've split them all into quarters. I know that whole is 4/4. That whole is 4/4. That half is 2/4. So in total, I've got 10 quarters, 10 fourths. I know that 1 1/2, 1 1/4 is the same as 5/4. So actually what I'm doing is taking 10 fourths and subtracting 5/4 from it. Well, that leaves me with 5/4. When I convert that back into a mixed fraction, I see it's 1 1/4. So two different methods to solve that problem. Both come with exactly the same answer, 1 1/4. Now let's look at yellow shirt. Same bag of, well, same size bag of flour, but she's used 7/8. So we got 2.5 minus 7/8. So the first thing I could do is turn my 2.5, and I can get rid of my 1, keep my 1, and then say actually it's the same as 1 whole and these 8. So I've turned my 1 1/2 into 8s. Bit confusing there. Don't worry if you are thinking, what is going on? Let's just go back 2.5. I know 7/8 is less than 1. but also I know it's more than a half. So I'm going to need 1 whole and a half. This is a bit like when we are doing subtraction and we have to steal from one column to put into the other column. I know that I'm not touching this whole kilogram. No, pound we're talking about, sorry, aren't we? This whole pound, I'm not touching it. So I'm going to leave that one there. But I am going to need this one. So I've split this one into 8s. And I've got this one in 8. So I've got 8 8s and I've got 4 8s. So that makes 12 8s. So my sum that was 2.5 take away 7 8s is now 1 plus 12 8s take away 7 8s. So I've just partitioned it out a little bit. And now I can do 12 8s take away 7 8s. Well, I know 12 take away 7 is 5. So that part is going to be 5 8s. And I've still got 1 there. So it's going to be 1 and 5 8s. So that's one method I could use. I could also have just turned the whole thing into 8s. So 1 whole is 8 8s, plus another whole is another 8 8s, plus a half is 4 8s. So I see that in total I have 20 8s. 28 take away 7 8s means I'm left with that 20 take away 7 is 13. 13 8s I then need to put back into my mixed fraction. So I realize that 13, 1 whole is 8, remember? So I've removed 8 of those 8s and I'm left with 5. So it's 1 whole or 8 8s and 5 8s, 1 and 5 8s. Both of those methods work. There's a different method for this one that I could have used as well. Have a look at this method. Can you explain what she's done? 2.5 take away 7 8s is the same as 1.5 plus 1/8. Well, I've given you a bit of a clue. There's a key here. A clue here, sorry. 7 8s. 7 8s is almost a whole, isn't it? But it's not quite a whole. It's 1/8 short of being a whole. So what she's done is said, well, look, if I just took away 1 whole instead of 7 8s, then I would have 1.5. But 1.5 means that you've taken away too much. You've taken away 1/8 too much. So you've got to give that 1/8 that you shouldn't have taken back. So 2.5 take away 7 8s is the same as 1.5 plus that 1/8 we weren't supposed to take. It's a little bit like change, isn't it? I was supposed to take away 7 8s, but instead I took away 1 whole. That means I've got to give back change. The change is 1/8 because I've taken too much away. And if this method doesn't quite make sense, it's not the end of the world. You might want to pause for a moment and draw it out. It's something that once you get your head around, it will make lots of calculations quicker, but it's a method that only works on certain calculations. It only works where you're subtracting something that's near a whole. And it's one that you can get yourself confused with if you're not really concentrating. So of the methods we've used so far, we know that method 2 in both examples, where we convert everything into an improper fraction, it's a fairly straightforward one. The danger is when we're converting back to mixed that we make silly mistakes. We've got for both calculations method 1, which is more about partitioning out our calculations, done in slightly different ways. Let's have a look again at some different sums. So here we've got a question. Find the difference between 3 1/3 and 1 8/9. So we've drawn it out here. 3 1/3, 1 8/9. So let's look at method 1. 3 1/3, take away 1 8/9. Well, the first thing we've done here is switch to the same denominator. So 3 1/3 is the same as 3 3/9. So now I can look at my calculation. 3 3/9 take away 3 3/9 take away 1 8/9. Now, what we've done here is something a little bit strange, because what we've realized is that I can't take 8 away from 3. So what I've done is stolen one of my wholes and I've added it in to my fraction to make an improper fraction. I've now got 12/9 there. I can take away 8 from 12/9. 12 take away 8 leaves me with 4/9. But don't forget, I've still got to take away 1 from my 2. So I started with 3 3/9. I couldn't take away 8/9 from 3/9. So I had to steal one of my wholes and add it into my fraction, making that 12/9. 12/9 is the same as 1 3/9. From 12/9, I could subtract 8/9. And that left me with 4/9. And then I just had to deal with my whole numbers. 2 take away 1, leaving me with 1. One method, lots of jiggling around there. The other method I might have used for the same sum, 3 1/3 take away 1 8/9, is to say that 8/9 is almost a whole. So I'm almost taking away 2. In fact, it would be 2, and what would the difference be if it's from 2, sorry? It's not 2, it would be 2, plus I'd have to give back 1/9. So now we start to get in a little bit of a confusing sum here, because now we're looking at our 3 1/3, and this is a bit like that method 3 in the last one. You've got to be really clear on what you're doing here, because there's lots of jumbling around. But 1 1/3 plus 2. So all I've done is take this 3 here, and I've separated that 3 into a 2 and a 1. Why have I separated it into a 2 and a 1? Hopefully you've realized, because we said that this is almost 2. So now I can almost forget about, I was about to use my fingers, I can almost forget about this 1 1/3 for a moment and look at my 2 take away 1 8/9. Well, 2 take away 1 8/9 leaves me with 1/9. So all I've done is look at this little bit here and said, actually, 1 8/9 is almost 2. So let's steal 2 from over here. Forget about the fraction. Let's just steal 2 and take away 1 8/9. That leaves me with 1/9 left. I'm going to add that 1/9 to that 1 1/3 I've just left behind for a moment. And to do that, I'm going to have to do some changing of my denominators to 9. I'm going to have to multiply my 1/3 into 9ths. So I do that by timesing by 3, times by 3. So it's 1 3/9 plus 1/9 is 1 4/9. So in this method, I partition my whole number to take away my fraction, because my fraction, again, was near to a whole. This is a method that can be a little bit confusing, and you might make a mistake with your adding or subtracting. You might want to draw this one out if you were going to use this method. Have a try on a piece of paper, and you'll need to pause the video, at these 4 calculations, A, B, C, and D. Okay. Let's just make it a bit bigger. So 2 7/8, take away 1 1/2. You might have used lots of different methods for this. and the answer would be 1 3/8. If you've expressed that as an improper fraction, it's fine, but really remember to simplify it down. Simple answers wouldn't be improper. B, 2 7/8. Take away 1 1/8. Lots of different methods you might have used here, but I suspect lots of you will have dealt with the fractions and then dealt with the whole numbers and seen that the answer to this is 1, and it would have been 6/8, which we can simplify down to 3/4. We've got 3 1/12. Take away 1 1/6. Again, lots of ways you might have dealt with this one. But most, I suspect, lots of you will have changed the fractions to have a denominator of 12, dealt with the fractions, and then dealt with the whole numbers. So, sorry, the answer is 1 11/12. In fact, sorry, you would have had to exchange one of those. And then lastly, D, 3 1/12 minus 1 5/6. So just like the last one, to do this, once we change our 6 into 12ths, we know that's going to be 10/12. That's greater than 1/12. So we are going to have to steal from here and add it into this fraction here. So this becomes 13/12 to do our subtraction. So both of these last two, you are having to do, it's like an exchanging or stealing like we would do in subtraction. I'm going to ask you to complete worksheet 14. The link is on the daily PDF. I'll just say it again, I said it earlier in the video. It talks about using Sally, Bob, Jim, Barry's, whatever's method. Don't worry about that. I'm not so worried about which method you're using. I am worried that you are able to find the answers. It would be really smart to try some different methods. Don't just stick to one of them. So don't just, for instance, convert everything to improper fractions. If you've mastered that, have a go at doing some other methods. See which ones you think work best for the calculation. So pause the video now, complete worksheet 14, come back and check your answers. Okay, and here are the answers for worksheet 14. Excellent. That's it for today.